Okay, so today we are going to discuss about gradient, okay, which we also call as slope. Okay, what do you mean by gradient or what do you mean by slope? Let me explain this thing with the help of a graph. For instance, I'm making a graph over here. This is my x-axis and this is my y-axis. Okay, this is x-axis and this is y-axis over here, and 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay, I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay, now I'm making a line over here. This is a line given to me, and when I will connect it, it will go something like this. Okay, now let me select any 2 point from this line, any 2 point at all. So first of all, I'm selecting these 2 points. Okay, I'm selecting these 2 points, and after that I'm selecting these 2 points. Okay, this coordinate is 1 comma 1 and this coordinate is 4 comma 4. Right? Now, if I will take the difference between y values, so how will I take the difference? 4 minus 1, right? And if I take the difference from here, that is also 4 minus 1. So when I will simplify it, this will be coming 3 upon 3, which means 1. It means that basically what I have done over here, I have taken the difference between y values, and over here I have taken the difference between x values. Okay, we also call it as rise. This is our rise and this is our run. Means at every point how much rise and how much run is being taken. If we take the ratio of that thing, this is called your gradient. Okay, so this is called the gradient, and in order to represent the gradient, we use the symbol of m. We call it as gradient or we call it as slope also. Okay, now I'm changing my value over here. This is 0, 2, 4, 6, 8, 10, 12, and 40. Okay, over here I'm taking 3, 6, 9, 12, 15. Selecting any 2 points. So I'm taking this one. Coordinates are 10, 15. First x value, then y value. And the second thing which I'm going to take over here will be, I'm taking this one, 6 and 4. Okay, so this will be 4 comma 6. Right? Now, when I'm going to simplify it over here, what will happen? Again, I'm trying to find out the gradient over here. I'm going to take out the gradient over here. So what will I do? First of all, I will see how much difference will be there between y values. So, taking difference between two y values, difference between y values divided by difference between x values, this is called your gradient. This is called your gradient. And if I want to show it numerically or in a formula, so I use y2 minus y1 upon x2 minus x1. That's the gradient formula, or that's the slope formula over here. Okay, so two values are here, 15 and 6. So I am taking this one as uh, x2 y2, x1 y1, or you can switch it also, it doesn't make any difference. So y2 15 minus y1 6 upon x2 10 minus x1 4. So 15 minus 6, the result will be coming 9, and 10 minus 4, the result will be coming 6, means the answer is coming 3 over 2 over. The result is coming 3 over 2. Now I am on the same line, I am selecting two other points to see okay what is going to happen. So see beta, over here, if I take these coordinate, this one is coming 2 comma 3, and I am taking this coordinate which is coming 8 comma 12. Okay, so what will happen now? If I have to find, now I'm using this point and this point to see what is my gradient is going to be. So over here, x1 y1 x2 y2. Okay, formula is y2 minus y1 upon x2 minus x1. Okay, so y2, what is my y2? 3 minus x2 is 12 over 2 minus 8. When I am going to simplify it, 3 minus 12 will be minus 9, 2 minus 8 will be minus 6, and when I will simplify it, the result is coming 3 over 2. Same like this one. The results are coming same. Okay. Now, let me take one value from one coordinate from first set and one coordinate from second set, and let's see either we are going to get the same result or not. So now I'm trying to find the gradient between these two. The gradient between these two. So x1, y1, x2, y2. When I will be finding the gradient, that will be y2 minus y1 over x2 minus x1. M equals to y2 value is 15, y1 value is 12 upon x2 value is 10 and x1 value is 8. When I will be simplifying it, my result is coming 3 over 2. So on a single straight line, you can take any 2 point, it's your total choice, but the gradient of a straight line will always be equal. Okay, the gradient of a straight line will always be equal. You can check it from here, here, and here. First, I have taken 4 comma 6 with 10 comma 15. Then I have taken 2 comma 3 with 8 comma 12. And then I have taken 8 comma 12 with 10 comma 15. The result is coming same. Okay. Now, question number 1 of exercise 7.3. They are giving us that we have to find the gradient of given line. Okay. They are saying find gradient of given line passing through some points, find gradient of line. And those lines are passing through some points. So what are the coordinates given to me? First one is given, A part is A 5 comma minus 2 and B 2 comma 1. Okay, this is given to me. So I know that the gradient formula is y2 minus y1 upon x2 minus x1. So x1, y1, x2, y2, right? So m equals to y2, that is 1, minus y1, that is minus 2, over x2, that is 2, and x1 is 5. So when I will simplify it, 1 plus 2 over 2 minus 5 will be minus 3. Simplifying it further, 3 over minus 3, and the result will be coming minus 1. That's the gradient for part A. Okay. Now, part C. In part C, they are giving us A t comma t and B t square comma t cube. And again, they are saying that we have to find the gradient of the line which is passing through these 2 points. Okay. So now I'm taking this one as x2, y2, and this one is xy, x1, y1. It doesn't make any difference between 2 points. You can take anything as x2 and you can take anyone as x1, y1. Okay. So simplifying it, m equals to y2 minus y1 upon x2 minus x1. M equals to, what is y2 given to me? T minus t cube over x2 t minus t squared, right? So m equals to t common 1 minus t squared over t 1 minus t, right? T and t will be cancelled. M equals to 1 minus t squared over 1 minus t. It's 1. 1 can have any power. The result will always be 1. So I can write it as 1 square. Okay. So if it is written as 1 square, so I'm using the identity a square minus b square, which is equals to a square minus b square equals to a minus b into a plus b. So this will become 1 minus t into 1 plus t over 1 minus t. These two will be cancelled and the gradient of the point is coming 1 plus t over here. Okay, the gradient of the point is coming 1 plus t, right? Now, D part of question number 1, again, they are giving us 2 points and they are telling us that we have to find the gradient of the point. The first one is given to me as a t comma t plus 2 and the other point they are giving us as b whose coordinates are given, and again they are telling us to find the gradient of the line. So it's given 3t comma 5t plus 2. Okay, 3t comma 5t plus 2 and t comma t plus 2. Now again I have to find gradient. I have to form okay, what will be x1, y1, x2, y2. So x1, y1, x2, y2. M equals to y2 minus y1 upon x2 minus x1. M equals to y2 5t plus 2 minus y1 t plus 2 over x2 3t minus x1 is t. Simplifying it, m equals to 5t plus 2 minus t minus 2 over 3t minus t will be 2t. So m equals to plus 2 minus 2 will be cancel. 5t minus t will be 4t over 2t. And when I am going to simplify it, the result is coming m equals to 2 for this part. Okay, the result is coming m equals to 2 for this part.